Okay, let's go to page 221, and this section is 18.6, Polyhedra. Okay, so polyhedron, a singular, is a solid figure whose faces are planar polygons. Okay, parallelipiped, prism, pyramids are all examples of polyhedra. Okay, a regular polyhedron is a the word regular means every face is identical or congruent. And here are some examples of the regular polyhedron. I mean, they are all different type of polyhedrons. Okay, but the regular polyhedron is the one all the faces are identical. And so over here there are a few. So these are information on the 5 regular polyhedron. So first one is the tetrahedron. Tetrahedron, every face is a triangle, so there are 4 equilateral triangles. So there are 4 equilateral triangles, and there are 4 vertices, and there are 6 edges. Okay, so you can count. The next one is hexa. So again, tetra means 4. Okay, hexa means 6. So this one has 4 faces. Hexahedron have 6 faces. So this is like a cube, okay, like a die. Again, you got 6 faces, and there are a number of vertices would be 8, right? 4 on top, 4 on the bottom. And number of edges would be 4 on the top, 4 on the side, 4 on the bottom. So you give a total of 12. The next one is the octahedron. Again, every face is a triangle, and there are 8 of them. Okay. And the next one is a dodecahedron, and every face is a regular pentagon, and there are 12 of them. So it looks like this. The next one is a icosahedron. Icosahedron, every one is a triangle, and there are 20 of them. Okay, so these are your regular polyhedron. Okay. And again, the relationship between the vertices, faces, and edges are this formula right over here. Okay, so this is an important formula to know. So vertices, number of vertices plus number of faces minus number of edges equal to 2. Okay. Okay, let's go to example 18-12. So when you do a 3-dimensional, you need to break it down into 2-dimensional. Sometimes it will help. But sometimes if you cannot, just have to be able to visualize the 3-dimensional. Okay, so it's from the volume of a regular tetrahedron with a side length of 1. Okay, so here's your A, B, C, D. And here's your N. So sometimes kind of harder to see, so I'm going to make the edges red. Okay, so here's your A, B, C, D. Okay. And each side is equal to 1. Okay, so what you need to do, you need to draw your median. Okay, draw your median. And the median will meet in a point is a centroid, right? So if this is a 1, okay, this would be 1/2 over here. This would be 1/2. Okay. And so this would be a 30-60 spatial triangle. So AM will equal to square root of 3 over 2. And again, this is your centroid. Call this O. So you would divide this into 3 parts. This would be 1 part. This would be 2 parts. Okay. So AM equal to square root of 3 over 2. So 1/3 of that. So OM would be 1/3 of that. So it'd be square root of 3 over 6. Okay. And AO. So this would be so again, this is square root of 3 over 2. Okay. And this is 1/3 of that, so it would be times by 1/3 give you that. And AO would be twice of that, so times this by 2, so it would be square root of 3. So 2, you simplify, you get 3. Okay. So once you do that, then you're looking for the volume, right? Okay, so the volume will equal to 1/3 the base area times the height, the altitude. Okay. Okay, so now if you look at the triangle ABO, okay, so AO is square root of 3/3, AB is 1, and BO is the H, right? So from here you can figure out the H. So use your Pythagorean Theorem. Okay, so A squared plus the B squared equal to C squared. Okay. Okay, so this will equal to 3 plus H, 1/3. So you're going to get 3/9, so 1/3 plus H squared equal to 1. So H squared equal to 2/3. So H will equal to square root of 2 over square root of 3. So H will equal to square root of 6/3. Okay. Okay, so we have the H. Okay, again you go off to the side so you don't clutter up your major steps. Now you have to figure out the base area. Well, base area is an equilateral triangle. Okay, so you have the A, C, D. Okay, with each side equal to 1. Okay, so area, so again this would be 1/2 and square root of 3/2. So the base area would be 1/2 base times height. So it would be equal to square root of 3/4. Okay, so now we can go ahead and work it out. So when you simplify, this would be square root of 3 and square root of 2, right? So this will cancel out with this one, and so volume would be equal to square root of 2/12. Okay, and that's it. Okay, so 3 dimension does get a bit complicated, but you just have to kind of break it down and work carefully. Okay, let's go to example 18-13. Okay, so find the volume of regular octahedron with a side length of 1. Okay. Okay, so this is A, B, C, D, E, F. Okay, so I can going to draw my H's. Okay, and each side equal to 1. And we're looking for the volume. Okay, so we need to go and drop this straight down. Okay, so here is the O, and I'm going to call this M. Okay, so if you just look at, okay, there are many ways you can do this. Okay, so normally you have to find these to find the surface area. If they ask you for the like a lateral area and whatever, then you need to look for EM and look for OM, okay, and EO. You have to find all that information. But since you're only doing the volume, I guess they're a bit easy. You can just go and do diagonally. Okay, either way. Okay, but anyway. So if you were to look at this over here, look at the triangle. So you got E, A, B, M. Okay. So each edge is 1. Okay. And so this would be 1/2, 1/2, and so this would be, so EM would be square root of 3/2. Okay, so this would be square root of 3/2. So now after that you look at the E, so you have to kind of turn it around, EMO. So this is square root of 3 over 2, and this would be 1/2, right? Because this is 1, so this is half, right? And so this would be the EO would be the H. So you kind of have to do two Pythagorean theorems. Okay, so over here again, you're going to get 1/2 square A squared plus B squared equal to C squared. Okay, so you work it out, so you got 1 over 4 plus H squared equal to 3 over 4, and your minus, so H squared equal to 2 over 4, and take the square root, so H would be equal to square root of 2 over 2. Okay, so this will equal to square root of 2 over 2. So once you figure out the H, now it's very simple, would be easy to figure out your volume, right? So volume would be equal to, okay, so it would be the base area, so it would be 1 times 1. Okay, let's do this. So it would be the base area times the height, okay, base area times the height, and you have to times by 1/3. So this would be 1/3, because it's a pointed top. Right, so 1/3, and then there one on the top, one on the bottom, so times it by 2. Okay, so that's going to write better. So volume would be the base area times the height. So this would give you the box, and because you are pointy top, so it would be 1/3. Okay, and because there's one on the top, one on the bottom, so you have to times it by 2. Okay, so you substitute everything in here. So volume would be 1/3. The base area is 1 times 1. The height is square root of 2 over 2, and there are 2 of them times by 2. So you work it out, and so the volume will equal to square root of 2 over 3.